Hey, hello, welcome. We're in Algebra 1. We are near the end of the third learning target, and in fact, we are right at the last lesson of the third learning target. Let's go ahead and get started. Here we've got a situation where we're now going to start solving for one variable in equations that have lots of different variables happening in there. These first few examples are pretty basic. You'll see they become more complicated. So there's a lot of examples, but they will increase in difficulty as we go along. So here we have this first one, which is a plus b equals c, and we're meant to solve for a. So what I like to do to show, and not everybody needs to do this, but it helps some people to put a box around the variable that you care about, because that's what the question is about. So since it's a we're after, I put a box around a. Now b is added to a, so we're going to need to subtract b on each side. And when you do that, you can say goodbye b's. So a equals c minus b. That's our answer. Okay, that's the first one. Now here's our second one. It's ab equals c, so a times b equals c. So I'm going to go ahead and put a box around a because a is the equation I'm supposed to solve for in the instructions. As I do this, I know I need to divide both sides by b, which means a equals c divided by b. There we go. Moving on. Here we're supposed to solve for c in this equation. So I'm going to rewrite it so I have something to work with. And since the exercise or example is about variable c, I put a box around c. That whole ab term is added to c, so that whole ab term needs to be subtracted away from both sides of the equation, and c equals d minus ab. That's it. Okay, here we're going to solve for b, and you're going to see that starting now, the examples are often going to be longer. That's just fine. But this time it's b we're after, so I'm going to draw a box around b just to highlight that that is the variable I want to keep at the very end. In this example, b is multiplied by a, and then c is added, so go ahead and subtract c first, because then goodbye c's, so ab equals d minus c. And now, since I'm after b, I need to divide both sides by a. So now the a's cancel on the left. b equals d minus c divided by a. All right, here's our next one. We have to go ahead and solve for r. So I'm going to go ahead and box up my r. d equals rt, so we'll need to divide both sides by t, since it's r times t in the equation. Dividing by t makes the t cancel away, so d divided by t equals r, and that's almost an answer. Much better version of the answer is r equals d divided by t. And here's example 6. V equals LWH. We've got an equation for the volume of a prism, like a box basically. Solving for W. W is right there. Now this one's a little bit tricky because it looks like it's in the middle, but look, W is multiplied by L and multiplied by H. So to solve it, we can just go ahead and divide by the L and the H at the same time. They both go goodbye. V over LH equals W. Or, better yet, W equals V divided by LH. Okay, that's example 6. We're halfway done with our examples. Here we have just kind of made up thing here where we're trying to solve for x. So again, as a help to people who need it, I draw a box around the x. You can too if you like. First step is to add the c, because minus c at the end. Say bye-bye to our friends the c's. xy equals p plus c. Keep going here. It's xy, meaning x times y. To solve, we divide both sides by y. Now goodbye to the y's. So x equals p plus c over y. Boom, there we have it. Example the 8th. Solving for x. Here we have an equation. This equation is about the perimeter of a rectangle. 2x plus 2y. You could call it 2 length and 2 height, doesn't really matter. But we're solving for x. I'm putting a box around it. Now here x is multiplied by 2. Then 2y is added on at the end. So we'll go ahead and subtract 2y. Remember, adding and subtracting always happened at the end of PEMDAS, so they are the first thing we do to get rid of. P minus 2y equals 2x. Now if we divide both sides, oh, there's the x, right? It's 2x, so divide both sides by 2. So p minus 2y over 2 equals x. But again, we can rewrite it to make it look like we know what we're doing. X equals p minus 2y over 2. Just rewriting it with the actual variable that's requested in front. All right. Example the 9th. Solving for r. All right, so v equals pi r squared. Good times. R is right there. This one, something kind of silly is going to happen, so I want to stay focused here. First thing is divide by pi, because it's pi times r squared. So divide by pi gets rid of the pi's, and v divided by pi equals r squared. Now the trick is you got to get rid of the squared, and the way to undo squaring, this might be new for you, is to do the square root on both sides. Square rooting is the opposite idea of squaring. And so v divided by pi equals r. Excuse me. The square root of v divided by pi equals r. And notice I wrote a little plus and a little minus in front of the square root. Whenever you're doing the square root to solve an equation, you're going to need to do that. And that's because if you take a negative number and you square it, it ends up as the positive number. So for example, we say the square root of 4 is 2. But if we're trying to figure out what's going on to make 4, it could be 2 or it could be negative 2. Because negative 2 times negative 2 is positive 4. That's a bit confusing. Listen, for this unit, for this class, throw down a plus or minus in front of the square root. And this whole business about square rooting to solve, that's a highly proficient skill. Okay, moving on to example 10. Solving for h. V equals 2 pi rh. By the way, this is actually surface area of a cylinder, or lateral surface area of a cylinder. I wrote V instead because, I don't know, thought people would be annoyed if I wrote SA as a single variable. Okay, anyway, doesn't matter. H is the variable we are after, and H is multiplied by 2 pi and r, so we'll go ahead and we will divide each side by 2 pi and r. Then the 2 cancels, the pi cancels, the r cancels. V over 2 pi r equals h. Better yet, h equals v over 2 pi r. We're getting near the end, folks. Couple more. We're going to solve this equation for h. It's v equals 3 pi r squared h. This is actually not a volume, it's a surface area of a sphere, a three-dimensional shape. Don't worry about it too much. Solving for h. Going to divide both sides by 3 pi and the r squared, because those are all multiplied by h at once. Pi by 3, pi by pi, pi by r squared. So v over 3 pi r squared equals h, or even more better yet, h equals v over 3 pi r squared. One more example to go. I'm going to solve this last one for r. It's the same equation as the last example, but we're solving for a different variable. Solving for r. So, divide both sides by 3 pi h, because those are all multiplied in by the r. Pi by 3, pi by pi, pi by h. So v over 3 pi h equals r squared, because the r was squared. Now this isn't quite done yet, so to get rid of the r squared, well, to get rid of the squared on the r, we'll need to square root both sides. So square root of 3 pi h, square root of v divided by 3 pi h is r, so r equals plus or minus the square root of v divided by 3 pi h. Again, the same business about the plus or minus in front. You don't have to worry about it too much. It's a thing. It's an actual thing. This will become a bigger issue in a couple of months in this class, but nothing that I need you to worry about too much today. Hey, thank you for watching. I know the plus or minus bit is a little strange, but if you have any questions at all, please let me know.